As you can see, we're going to take a look at the problems from page 463, and the focus of this is to find the volume of solids of revolutions. And these particular solids are going to have holes in them because there is some distance between the region that we're going to revolve and the axis we're going to revolve about. So in problem number 5, the directions tell us we're going to revolve around the x-axis. We're looking at the curve y equal to x squared, which is a parabola, and y equal to x cubed, which of course is a cubic function. So that gives us this region right here that we're going to revolve about the x-axis. Now I'm not going to do this every time, but if we draw the reflection over the x-axis, we would have a region that looks something like this. So there's that. Of course, it's not great. There's the reflection, and so when we do that circular motion around the x-axis, we're going to get this solid region on the outside. It's solid on the outside, but there's clearly a really big hole over here on the right side, and the hole gets smaller and smaller and smaller as we go through the region. So our job is to find the volume of that solid, and it's based on geometry. Remember, I talked about in the lesson that because we do a slice, and because we're going to have a hole, again, because that region is not flush to the axis of revolution, to find, based on basic geometry, the area of the donut, as you might say, we're going to need to find the radius of the big circle, and we'll call it big R. And the area of the big circle is pi big R squared. That's the area of the big circle. Now what we're interested in is just finding the area of this region right here. So now we're going to have to find the area of the small circle, which has a small radius. We'll call it little r. So we'll take the area of the big circle minus the area of the little circle, and that will leave us with the region that we're trying to find the area of. So that's kind of the principle behind what we're doing. So let's set up problem number 5. Because we know that we're going to have a hole, again, the region is not flush to the curve, we're going to have a big R of x and a little r of x. This little region right here, like we discussed the last time we saw this from the textbook problems, that's our representative slice. Don't let the little rectangle throw you off. So our representative slice goes from the top curve to the bottom curve. All right, so when we revolve that around, we're going to have, as I said, a big radius and a little radius because there is a hole in the region. All right, now, just a reminder, big R always goes from the outer curve minus the axis of revolution. That's the distance of that radius from the outer curve. So in this case, it would be from the outer curve is x squared to the axis of revolution, which in this case is the x-axis. So if we take the top curve or the outer curve, which is x squared, and then I'll move that little r down, outer curve minus the axis of revolution, which in this case is 0, then the distance or the length of big R is x squared. All right, if we do likewise, the little r, the inner radius, would be the inner curve minus the axis of revolution. The radius is the distance from the curve to the axis of revolution. So the inner curve, oops, let's go in red. I thought I had it in red. The inner curve is right here. And so if we measure that inner curve to the axis of revolution, we would get x cubed, the inner curve, and minus the axis of revolution, which gives us x cubed. All right, so now that we know our radii, that's really the big idea. We're going to do, remember, the area of the big circle area. So big circle area minus little circle area. All right, let's figure out where we're going to start the area accumulation. So the first point of intersection, which is given to us in this case, is 0. and the second point of intersection is 1. We are in terms of x, so everything is in terms of x, including the bounds. We're going to start at 0, and we're going to go to 1. So we're going to have big R squared, so that's going to go in blue. So here's my R, and we're going to factor the pi out front. Remember, both circles are going to have pi R squared, pi R squared. So we can factor the pi out front. So we have big R squared, so x squared squared, minus little r squared dx. So that is our setup for finding the volume with a hole in it. So that'll give me pi 0 to 1 x to the 4th minus x to the 6th dx. I'll take it through the integration, and then you can check the solutions manual. I'll give you the answer. So you have pi from 0 to 1 of x to the 5th. Whoops, I'm integrating, so I don't have an integral symbol anymore, will I? All right, let's erase that. All right, let's back up and do that again. That'll give me pi x to the 5th over 5 minus x to the 7th over 7. Evaluated from 0 to 1. Always be thankful for zeros. So when we substitute, we'll get pi times 1/5 minus 1/7 minus 0, because when we substitute 0, we'll get 0 in both terms. Common denominator will be 35. So I have pi times 35. That'll be 7 minus 5, which will give me 2 pi over 35 for the volume of that region. So that one I decided to work out all the way through. All right, for the next problem, we're going to look at problem number 6. Let me clear those annotations. That's going to get rid of my highlights and I think my box, but that's okay. All right, problem number 6, same situation. We have the axis of revolution is the x-axis, so that's right here, and there's clearly a lot of space between the region that we're revolving and the axis of revolution. Because we're around the x-axis, we're going to be in terms of x. The top curve is the parabola, the bottom curve is the horizontal line y equal to 2. So big R of x, always distance from outer curve to the axis of revolution. So that distance would be outer, so 4 minus x squared over 4, and again in this case minus 0. So the big R is that distance right there. Little r is the distance from the axis of revolution to the inner curve. So here's the inner curve. Here's the axis of revolution. That's going to be little r. So little r of x is top curve, which is 2, minus the bottom curve, which is 0. So little r of x is 2. All right, we know we're going to have a hole. We can clearly see a lot of space between the region and the axis of revolution. So we're going to have the common pi. We have two circles. We can factor out the pi. We're going to be in terms of x, and we can see that we're starting at -3. Stopping at 3. Now one thing you could do, because of the symmetry here, you could go from 0 to 3 and double your answer. I'm going to have big R, 4 minus x squared over 4 squared. Big R squared minus little r squared. All right, so as I look back at that setup, I'm noticing that I don't think that the start and stop is -3 and 3. I think I made an assumption there. So I'm going to set these two curves equal to each other to make sure, because I don't think that this is -3 and I don't think this is 3. So if I set those two curves equal to each other, I get 4 minus x squared over 4 equal to 2. Subtract 4 from both sides, and I get negative x squared over 4 equal to -2. Divide both sides by -1. Multiply both sides by 4. I get x squared equal to 8. So x is actually equal to the square positive or negative square root of 8. So I was correct. These bounds are not negative 3 to 3, so be careful about making assumptions. So negative root 8 to positive root 8. So now I think since these numbers are square roots, I think I do want to take advantage of my symmetry. So watch what I'm going to do. Instead of going from negative root 8, which is right here, to positive root 8, which is right here, I'm going to use this beautiful symmetry, and I'm going to double, watch carefully, 2 pi, and I'm going to go from 0. See, this is one of our properties of integrals. We have an even function, so I'm going to go from 0 to square root of 8, and that way I simplify my arithmetic when I have to evaluate the problem. Okay? All right. Let me square this binomial. So I'll help you out with the algebra here. So that's 16, and then 4 times negative x squared over 4 is just going to be negative x squared, and doubled is going to be 2x squared. And when I square the last term, I'll get plus x to the 4th over 16. So be careful with your squaring. Minus 4 dx. All right, now I'm going to combine like terms, and I will end up with 2 pi 0 to 8, still cleaning, still doing the algebra. So that'll give me negative 2x squared. That's not the first term, is it? That'll give me x to the 4th over 16 minus 2x squared, and then I have 16 minus 4, which will give me 12 dx. I'm going to find the antiderivative of that. That'll be x to the 5th over 16 times 5 is 80 minus 2x cubed over 3 plus 12x from 0 to square root 8. I think you can see why I decided to leave that to use the doubling and get that 0 in there. So that's going to give me 2 pi, and then I'll have, I'm going to write this as 8. How am I going to write this? I think I'll write it as, I'll just do this. Square root of 8 to the 5th over 80 minus 2 square root of 8 cubed over 3 plus 12 square root of 8, and then of course I'll have minus 0, and honestly just leave your answer like that. You don't need to clean that any further. Alright, let's go on to our next problem. So let me clear the annotations. We're going to 11b. So 11b, let me circle that or I will lose sight of what I'm working on. Alright, so now we go into the region where they have not provided graphs, so we're going to have to sketch a little graph for ourselves, and we're also this time going around the y-axis. So everything will be in terms of y. Got to think about all that stuff. So I have y equal to square root x. So square root of x looks like that. And then I have the horizontal line, y equal to 0, which is the x-axis. So what I'm trying to figure out is what is the region that I'm actually trying to revolve. And then I have the line x equal to 4, which is a vertical line. So here is x equal to 4. So the region that we are revolving is this region right here, which I would actually want to undo that because I need to write in there. All right, now when you look at that blue curve, there is distance between the y-axis and the region that we're revolving. So here's the y-axis. The region is not flush to the y-axis. Okay, get your mind thinking about this because we are in terms of y because we're revolving about the y-axis. So this time we're going to have a big R of y, not x, and a little r of y. That's reminding me that everything is in terms of y. So the big R always travels from the outer curve to the axis of revolution. So the outer curve is right here, all the way to the axis of revolution, which is right here. And so no matter where you put in that radius, big R is going to be 4, which is actually kind of nice because we don't have a variable function to deal with. Now the next one you're going to have to be also very careful. The little r always travels from the axis of revolution up to the inner curve, or from the inner curve, which is right here, the blue, to the axis of revolution, which is the y-axis. That radius is changing depending on where we put it based on the curve. But here's the thing. We need this in terms of y. So this is not going to be r of y equals square root of x. Clearly it's touching the square root of x curve. But I'm going to take that and put it in terms of y. So x, when I square both sides, is equal to y squared. So this blue curve, in terms of y, is y squared. So little r of y is going to be y squared. It changes depending on where we put it because the curve is changing. All right, let's set up our integral. We have pi on the outside because both circles are going to have a pi. The bounds in this case are going to be the lowest y value that we see is a y value of 0. The high y value is right here. That's the highest y value. I know the x value, so I'm going to substitute that 4 into this function to figure out the y value that corresponds to it. So the square root of 4 is 2, so this y value up here is 2. So we're going from a low y of 0 to a high y of 2. Big R squared minus little r squared, and that's my integral. I'll take it one more step and then I'll tell you the answer. So pi from 0 to 2, I'll take it 2 more steps, gives me 16 minus y to the 4th dy. I'm going to find the antiderivative, so that'll give me 16y minus y to the 5th over 5. Evaluate it from 0 to 2. And so for 11b, when you do your arithmetic carefully, you should get 128 pi over 5. If you have trouble with the arithmetic, let me know in class or in a support session, and I'll be glad to help you out. So that's 11b. All right, let's get rid of that. And let's go to 12a. 12a, we're working around the y-axis again. We're going to need to make a little sketch. So here we go. All right, let's start with our x and y axis. Let's get the pen. There we go. All right, so we will begin with 2x squared, which is a parabola opening upward. There's my parabola. And then I have y equal to 0, which is the horizontal line. Sketching the accurate and correct region is critical. So there is, whoa, 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 whoa. That's so ugly. So there is y equals 0. X equal to 2 we'll deem to be right here. So be really, really careful. The only region in this case that we are revolving is this region right over here because it's bounded by the blue curve, the red line, the green line. So the region on the other side, you can even actually get rid of it if you want to get it out of your way. It's not going to play a part in us finding the volume. Now we are going around the y-axis, so everything is in terms of y. Y bounds, big R of y, little r of y. So big R of y, little r of y. So let's figure those out. Big R of y travels from the outer curve to the axis of revolution. And no matter where you would put that segment, that distance is going to be a fixed radius of 2. That radius will always be 2. Little r travels from the inner curve to the axis of revolution, and that does change depending on where we put it. So little r of y is from the blue parabola to the y-axis, but we're supposed to be in terms of y. So I'm going to take my y equal to 2x squared, and I'm going to get x by itself, so I have y over 2 equal to x squared. X is equal to, this is really important, plus or minus y over 2. Now look at the parabola. I'm only dealing with the positive side. So when I choose big R of y, I'm only going to choose the positive side. So that's going to give me y over 2 is the distance from the inner curve to the axis of revolution. Let's set up our integral. So we have pi on the outside for both circles. The lowest, if you look at the region, the lowest y value is a y value of 0. The highest y value is here. So just like before, I'm going to have to substitute into this equation to get the corresponding y value. 2 squared is 4 times 2 is 8, so we have an upper bound or an upper y value of 8. Big R squared minus little r squared dy. That'll give me 0 to 8, 4 minus, whoops, I already got the minus there. 4, squaring the square root drops the radical. I get y over 2 dy. Finding the antiderivative will give me 4y minus y cubed over 3. Gotta love those zeros. 0 to 8. And when you evaluate that correctly, and make sure you do it, don't just jump to the answer. Let me find that answer for you. So while I was looking at that answer, I just also noticed an error in my integration, so glad I took the time to look at that. So the integration would be y squared over 4. Hopefully you caught that. Whatever, I was looking at the 2 in the denominator. So y squared over 4, and when you evaluate that accurately, you will get 16 pi. All right, let us go to, I think there's one more. That is number 14a. So 14a sends us back to the x-axis. So this one is going to have a parabola. We're going to have to figure out what the vertex of that parabola is. All right, so here is the axis, x, and y-axis. All right, so let's look at, we have y equal to negative x squared minus 2x plus 6. We've talked about this before, but I will remind you that the vertex of a parabola in standard form, the x-coordinate is negative b over 2a. So in this case, that would be the opposite of negative 2 over 2 times negative 1. So that'll give me positive 2 over negative 2, which is negative 1. So the vertex of this parabola is the x-coordinate is negative 1. To get the y-coordinate, I'm going to substitute negative 1 back into the parabola. So negative 1 squared would be 1. The opposite of that would be negative 1. Negative 2 times negative 1 is 2 plus 6. 6 and 2 is 8 minus 1 is 7. So the vertex of our parabola is at negative 1, 7. So here's negative 1. Here's 7 up here. And the parabola opens downward. So there's a downward opening parabola. It's just kind of giving me a look at what's going on here. Now let's go to the line y equal to x plus 6. So we have a y-intercept of 6. I'll just kind of deem it to be there with a slope of 1, positive 1. So our graph would look something like that. So the region that we're trying to revolve, and I have to be careful because I might mislead myself. I don't think that's necessarily an x-intercept, nor do I believe it goes below the x-axis. So I'm just going to do that. All right, so the region that we're trying to revolve is this enclosure with the blue curve on top and the green line on the bottom. We're revolving around the x-axis, so we are in terms of x, and I have a lower x bound here and an upper x bound here that I don't know. So this is our first problem. We have to actually find the bounds by setting the two functions equal to each other. So I have negative x squared minus 2x plus 6 equal to x plus 6. It's a quadratic, and I'm going to make it equal 0 by adding x squared to the right, adding 2x to the right, and subtracting 6 from both sides, which will make a 0. I'm going to factor x out of both terms, which will give me x plus 3. And so I have x equal to 0 and x equal to negative 3. So my graph's not fully representative, but this is an x value of negative 3. This is an x value of 0, even though it's not hitting the x-axis. Remember, it's a sketch. It's not perfect. So here we go. We're going to have a big radius, a big R of x. We're back in terms of x, and a little r of x. Big R travels from the outer curve to the axis of revolution. So top minus bottom. The top curve in terms of x is negative x squared minus 2x plus 6, and the x-axis is 0, so technically minus 0, top minus bottom. For the green line, we're going to travel from the inner curve to the axis of revolution. So we're going to have top, which is the line, x plus 6, minus bottom, which is 0, so we just get x plus 6. All right, here we go with our integral. Everything is in terms of x, so we have the lower bound of negative 3 that we found, upper bound of 0. We're going to have big R squared minus little r squared dx. Everything is in terms of x. All right, now we're going to have some fun times because we're going to have to square a trinomial. So let me make myself some space here. Just kind of show you how to square the trinomial. Hopefully you know what to do, but it is what you think it is. We got to write it twice and multiply it out. So that'll give me negative x squared minus 2x plus 6 times negative x squared minus 2x. Make sure you copy this right. That's usually my mistake. All right, so now we're going to multiply negative x squared by everything. So positive x to the 4th, positive 2x cubed, minus 6x squared. All right, that takes care of x squared. Now I'm going to multiply negative 2x by every term in the second one. So that'll give me plus 2x cubed plus 4x squared minus 12x. That takes care of the 2x. I'm going to take care of the 6, minus 6x squared minus 12x plus 36. All right, let's combine like terms. I have an x to the 4th, so that's gone. I have a positive 2x cubed and a positive 2x cubed to give me 4x cubed. Let's see. I have a negative 6x squared. Negative 6x squared gives me negative 12x squared. Plus 4 gives me negative 8x squared. So that's gone. I have a minus 12x and a minus 12x for a minus 24x. And then I finally have my plus 36. That was fun. All right, and then from that, I have to square the binomial. So here, when I square that binomial, I'll get x squared plus 12x plus 36. All right, so let's see if I can get those things combined. All right, so I have x to the 4th. I don't have any cubes back here, so I have plus 4x cubed. Now I'm going to try to go carefully. I have my minus 8x squared minus an x squared makes minus 9x squared. I have a negative 24x minus 12x makes minus 36x. Come on, eraser. There you go. Minus 36x. And then I have my 36 minus 36, which makes a 0, dx. And then lastly, or last thing I'm going to do right now, oh, thank goodness for that 0. So we have pi times x to the 5th over 5 minus, that'll be 4x to the 4th over 4, so that's just x to the 4th, minus 9x cubed over 3, which will just be minus 3x cubed, minus 36x squared over 2, so that'll be minus 18x, evaluated from negative 3 to 0. And that's a plus right there. All right, so thank goodness for the 0. So now be careful, that's going to give us, if I substitute 0 in all these terms, it's 0 minus parentheses, and then I'm going to substitute the negative 3 to the 5th power divided by 5 plus 3 to the 4th minus 3 cubed is 27 times 3 is 81. 3 times 18 is 54. And then when you finish that arithmetic, you will ultimately get 243 pi over 5. All right, so I hope it helps.